modern life would be very different without today's maritime industry, where 90% of the world trade depends on shipping. There are more than 50,000 ships traveling the seas transporting cargo, fuel, or passengers. These ships and other offshore facilities such as mining platforms, offshore wind farms and offshore ports are mainly built from steel, which although strong, durable and cheap, is in constant battle against the persistent natural enemy, which is corrosion due to iron oxidization, rust. Every year, corrosion costs the maritime industry between $50 and $80 billion in monitoring and maintenance against corrosion. The current tools to safeguard these metal structures against corrosion use ultrasonic or magnetic sensors and are expensive. The SMARTAQUA project seeks to change this trend by developing an innovative, low-cost and eco-friendly technology which will enable the maritime industry to detect corrosion on metal structures easily and at an early stage, before the corrosion turns into expensive damage. The use of environmentally friendly nanomaterials, that is, high-tech materials that are manufactured and worked at a very small scale, in the range of billions of a meter, reveal corrosion in ocean-faring steel structures before rust becomes visible. The SMARTAQUA project involved researchers from Portugal, Norway and Malta and was coordinated by Professor João Tedin from the University of Aveiro in Portugal. It was funded through the MarTERA ERA-NET Cofund Partners Foundation for Science and Technology of Portugal, Research Council of Norway and the Malta Council for Science and Technology. Scientists from the University of Aveiro developed two types of nanomaterials. The first type was developed for colorimetric detection. Iron ions resulting from the corrosion of steel give a blue color on the surface that can easily be seen by the naked eye. This is very useful for detection in the splash zone. The second type developed were iron oxide magnetic nanoparticles that make magnetic detection of corrosion easier to detect for submerged surfaces. The materials were laboratory tested by ecotoxicologists from the University of Aveiro to ensure that they would not have a negative impact on marine environment. In the meantime, scientists from AquaBioTech Group in Malta tested the materials created for antifouling properties to stop the growth of marine animals, such as mussels, on submerged steel structures. In Norway, the researchers from SINTEF Industry developed paint-like coatings which include the developed nanomaterials so they can be easily painted onto metals. The coatings were then tested by AquaBioTech Group scientists using ecotoxicology assessment to find out if any of the coating materials could be toxic to marine life. The experiments were carried out at the Good Laboratory Practices certified AquaBioTech Group's laboratories using marine microalgae and brine shrimps. Once the laboratory testing certified that all the materials worked as expected and were safe, the final coatings were produced and applied to steel plates that were tested by AquaBioTech researchers in realistic field conditions in Marsa Harbor. These demonstration tests were also successful, and the researchers were able to see blue spots on the coated plates after only 1 day in the sea. The brown rust spots, representative of advanced corrosion, became visible only after 7 days. The magnetic methods also found the corrosion before rust could be seen. The field tests confirmed that using the SMARTAQUA coatings, corrosion can be detected quickly, both visually and magnetically, without the need for expensive equipment. The technology developed by SMARTAQUA was possible through the coming together of scientists from different countries and the funding from the respective MarTERA partners. The funding from the MarTERA ERA-NET Cofund was crucial to bring together scientists from different backgrounds, such as chemists, material engineers and biologists, to work together on this project to improve maritime technologies. MarTERA is an ERA-NET Cofund scheme of Horizon 2020 of the European Commission with the overall goal to strengthen the European research area in maritime and marine technologies as well as blue growth.